All right, you've made it to the last session of the CTO Advisor virtual seminar. We have Karen Lopez moderating a panel of a pretty interesting set of characters from Andy Banda, who has had over 30 years of experience writing software defined storage bits. He is the godfather of iSCSI in VMware vSphere. We have Ray Lukichi, who's the founder and CEO of Silverton Consulting, who's also my fellow co-host on his podcast, Gray Beers on Storage. He's been the industry analyst way longer than I can account for. And then there's Enrico Signoretti, who is the lead analyst for infrastructure and storage over at GigaOM. They're about to get into it. This is at parts hilarious, but always entertaining and insightful commentary around this aggressive blog post by MinIO, which called the object storage the new primary data. I took offense to that claim because I know a lot of people who have primary storage outside of object storage and continuing to grow and continuing to make more of it. So I kind of lobbed this into the team to talk about primary storage. What is it? What isn't it? And how do you make purchasing decisions based on those definitions? Completely entertaining session. Hope you enjoy it.
Thank you so much. And I welcome all of you for joining us today. We've got this abstract that talks about primary data and primary storage, makes some references to a video interview that Keith participated in and some announcements. So we're going to talk about some of the futures of storage and high performance computing, as well as I'm going to be asking our panel to weigh in on what they think is the future of storage and high performance computing. But let's get started first. And I'm going to start with Enrico here. Enrico, what's your definition of primary data and or primary storage?
So, primary storage is where your primary data sits. I mean,
Okay, that was a little bit of a cheat, so but I'll let you continue.
no, well, I mean, so in the past, we were thinking about structured data as your primary data. Okay, so databases,
Mhm.
your SAP data, your ERP in general, or whatever, your Oracle. But it's true that today we are producing different types of data. There are even a lot of machines producing data that are very valuable for our organization. For they are really mission critical sometimes, and they are not stored in database or not in traditional databases. And so the type of storage that you use, it could be file, it could be object, it could be block. It's your primary storage depending on the data that you store in it. So maybe we can talk about the characteristics of primary storage in terms of reliability, availability, etc., etc. But actually, the main definition I think today is, you know, primary means critical, and that's it.
Okay. Okay. Ray, what's your definition?
I agree with Enrico to a large extent. I mean, primary data is the data that your critical applications for your enterprise or organization use, and primary storage is where you access that data from. It can be block, file, or object, and any of those are valid approaches to those sorts of things. I think the challenge we have today is that, with buffers and caching and direct access storage as well as networked access storage, the challenge about where that data resides is much more difficult. I think it can reside pretty much anywhere, but when it actually is processed, it's processed in memory of the application. So how it goes from where it was to in memory is part of the question that needs to be answered here. I'll leave that at that.
Okay. And Andy?
Okay, and I'm actually going to slightly disagree with both of those. Where I pretty much agree with the idea that primary data is the primary set of data that you work on, databases, objects. I always like to include virtual environments, anything that is the data critical to actually running your business. Where I'm going to disagree is that primary storage is actually is the place that you store data, and the difference here is that it's primary storage is not a chunk of software. Primary storage, you actually need some way to actually hold that data, whether cloud storage is fine or physical storage inside your own environment. But I don't I don't I don't agree with the idea that primary storage can be served up by a lump of software.
Okay,
Huh?
so that's interesting.
Are you crazy? Are you nuts? The whole world has moved to software-defined storage. How can you say it can't be served up by software? You
I
are
no
crazy,
no
Andy.
no I fully agree that there's software. There's always been software in front of storage.
Always,
There's always been
always,
software in
always.
front of storage.
Now
That
we have
doesn't.
software-defined storage, Andy.
Yeah, I mean, I've been software defining storage for 30 years.
Good for you. Me too.
That's true. That's true.
Oh,
Uh,
that's
but
great.
but at the end of the day, you can't
You said the
actually
H
store
word. You
bits.
said the H word.
You can't actually store bits in software.
Okay. Media. You need
Oh,
Okay,
media.
you need the full infrastructure. You mean? I mean,
Yeah.
the
I'm just gonna.
storage is part
Yeah, right,
software, part
and I mean
hardware anyway. Yeah.
this is part of where I'm going to jump right in and actually, you know, go back to where some of this discussion started with. I don't consider middleware to be primary storage. So we at Storage Field Day and at Tech Field Day, we talked to a handful of different middleware vendors, and yes, they offer valuable services for your primary data, but they are not primary storage. They are middleware that sits on top of your primary storage.
Hmm, interesting. I'm just going to slide in with a side story. I once worked for a national retailer in the US that indeed kept a ton of data in their software, like right in the code. The prices for all their items, all their SKUs, all the
There you
descriptions,
go. It's all
right in
software.
their code, because the two guys who originally wrote their point of sale system had no software background, but they knew a lot about video store rentals. And so that's how they didn't need a stinking database. They had
There you
code.
go.
I
But
thought that was good.
at the end of the day, their program existed somewhere.
Yes.
It didn't just sit there and RAM the entire life.
Andy,
Yeah,
talk to me about what you consider middleware in this space.
Oh yeah, good.
I mean, it's well, since Keith actually brought this up as a discussion about MinIO claiming that they are primary storage.
Let's not use vendors' names.
Okay, since
Okay,
Keith
you can
brought
use
this up,
vendor names, Andy.
but so that's what I consider middleware. Middleware is a software presentation layer that gives you your
But
access to your
every
primary data.
storage device in the
Oh, let
world,
him
every
finish.
software-defined storage system in the world, every system out there is essentially middleware between you and the disk, or you and the SSD, or you and whatever platter out there, and memory. Every one of
Right,
those is middleware.
but in lots of cases, the middleware actually comes with the primary storage necessary to serve it.
Are we?
Oh,
Yeah,
so if it's separate, it's different? Give me a break.
No, it
Would you
is
say
different. Yes, it is different.
No, it's
yeah?
not.
Oh wow, I love this. So one of the things I wanted to throw
I'm
in
sorry,
because
but
I was
primary storage has to be able to store bits.
Okay.
okay.
But that doesn't mean it can't be middleware storing bits, or an appliance storing bits, or software sitting on a server someplace storing bits and direct access storage. All those things store bits, Andy.
No, they don't. They handle bits. They pass bits from one place to
yeah.
another. They do not actually store the bits.
I think we're getting into a philosophical discussion. I recognize this because I've sat through plenty of what is a customer discussions in my life, and that's where we're going down. There's no end to that. But I appreciate so much the different points of view. One of the things while I was researching this topic, I came up with, because it was triggered a little bit by a discussion with academics at a research university. is that researchers use the term primary data to mean the data, the source data that was collected and has not been altered or enhanced in any way. And secondary data is data that is the result of analyzing it, doing compute on it, enhancing it. So just throwing those terms out there. So now I
Boy,
want to say,
that's really
Yeah, that's
different
raw
than
data,
oh yeah,
maybe.
that's really different. Like don't let me shock you guys that researchers use completely different terms when they talk about compute than we do. But the only reason I bring this up is, of course, if there's primary storage, there must be secondary storage and tertiary storage. Like I kind of understand the difference between primary storage and secondary storage, but I'd like to hear you guys tell me, why do we need to make that distinction of primary storage versus secondary storage?
Well, if I can start here, I mean, so your primary storage is probably the storage you access the most anyway. So,
Mhm.
so you access it more frequently. So there is also a performance component to this, to your primary storage anyway. Even if we are talking about object storage that is notoriously slower than block and maybe file. So,
So is it a way of archiving data, cold storage? What are we
well,
doing?
I think the distinction is much more complex to do today because you have tiering, you have, everything is hidden behind the scenes. So even if we are not talking about, sophisticated mechanisms to archive data and maybe, having a secondary system to move data away and make it searchable, or even long-term data like tapes or whatever. We're talking about much more complex infrastructures today than in the past, and so the dealing, I mean, the border that there is between primary, secondary, and tertiary storage is very complex to define. Think about, there are some vendors today, primary storage vendors, and again, and yes, it's an appliance, and where you store your data. But in the backend, they can do operations to move, snapshots and blocks that are less used to object storage. One can't work without the other in the end. So they in from your point of view, you see the front end, and maybe the front end is the latest NVMe technology or whatever, but you can't separate the block store or the file store from the object storage in the backend, because some of the information were moved to a secondary tier. Okay, and you do this mostly to save money, to have a an instant backup, or many other reasons. But actually, so primary, secondary, and tertiary storage is a little bit more complex to define than in the past, depending again on the use case and
Mhm.
how hot or critical is your data.
Yeah.
yeah,
So
I
Ray,
completely agree.
I saw you nodding your head, because so my follow-up question, which I think you're going to go to, Ray, is that do we make these distinctions for cost, for environmental impact? Why do we need to make these? Why isn't everything just
So yeah,
primary storage?
historically, primary, secondary, and tertiary were effectively archive layers, right? So tertiary would be very very cold storage. You very rarely referenced at all, and you never updated. Secondary was a little bit more updatable, a little bit more accessible, but again, not very quick to access and lower cost. Each of those tiers is intended to be lower cost, but slower performing and lower, all those things. So yeah, it's a more greener environment, so it's more sustainable kind of view of the world. If you can move most of your data to secondary or tertiary storage, you're talking cheaper and more economical and more or lower energy consumptive storage.
Right, and I do agree with those definitions. I mean, what I was going to say is
You're
your
kidding,
primary
Andy. It's the first one you've actually agreed to here.
primary storage is the storage that you need to be able to access immediately at a moment's notice. It's what you work on every day. It's what your customers need every day. It's the type of stuff that needs to be at your fingertips. And secondary storage is typically something that can be accessed fairly readily, but is not going to be there as quickly, is not going to be able to deliver it to you as quickly. And it's, the secondary and tertiary levels are the places that you need to be able to refer to, uh, if for some reason data is lost, or you need to be able to show some accountability for how you got to your primary data in the first place.
Mhm. That's interesting.
And it's, I mean, it
Yeah,
kind of turns your researcher analogy on its head, because um,
Exactly.
I mean, the idea that your primary storage is going to be what's at hand right now, and your secondary and tertiary storage are going to be the archival references that you can potentially say, this is how we know our primary storage is good.
hmm yeah. Like I remember from, just to name drop here, my visit to CERN, that they, at least the time I was there, which was probably about 7 years ago, they relied heavily on tape backups as a secondary and tertiary storage, not just for cost savings, but because they believed that it was better for the climate to make rarely accessed data not to be on a drive on a machine that needs to be turned out. Now they had to provide environmental protection for the tapes, but there,
Yeah.
besides the cost savings of not having it online, was the savings of energy usage, which I think we don't talk about that much.
Well,
But
actually, in many enterprises, it has become, the
yeah,
one of the major reason to change, storage infrastructures. I mean,
yeah,
hard drives are really, really power hungry compared to flash drives now, and with flash drives, you can use techniques, optimization techniques that you with hard disk drives are very difficult to implement.
hmm
So it's true that there are many vendors now focusing on QLC, so the latest um,
Storage
storage
media.
technology,
Yes.
media technology, just to lower down power consumption, make it more efficient, smaller also, so to have a less footprint in the data
Well, right.
center. So,
But just like tape, you can power off disk drives, and you can power off SSDs, and that technology has been around for a while. The difference with SSDs is that you don't actually have the spin up time to actually make them accessible. That you can apply
Right.
the power to them and have them accessible almost immediately.
hmm
Right.
yeah,
Right.
for
Right. The
sure.
yes, and
homemade thing.
Like
Yeah.
I have enjoyed reading vendors' sustainability reports that seem to show more than just, hey, we went out and had this report commissioned to show that we're green, but where they're actually talking about their design and architectures that are, you know, sending some thoughts into making things more sustainable for their hardware, even, right?
yeah, but the problem. So if you look at a large organization and they are still thinking about siloed department or siloed teams working on different application, each one with a single budget, then it's really difficult to talk about environment and sustainability, etc. Because they are wasting a lot of resources anyway. So even if they are purchasing the best array in terms of power efficiency, they are using just a fraction of it.
Yep.
Okay, so the
Yep.
mentality should change, at the top, and say, okay, you are going to share more resources, you're going to use the resources better, and then you can start thinking about, because even the discussion about tapes, yes, tapes in terms of power consumption, when they are stored properly, power consumption is zero. Okay, but you can't build a tape infrastructure if you have just hundreds of terabytes of data. I mean, it doesn't make any sense. You need petabytes and petabytes just to start thinking about it.
Yeah.
Yeah.
So
Yeah, and
Yeah.
that also impacts data quality issues as well. Like I know on my side of the world, grant driven research or silo driven projects leads to a lot of data waste and duplication of data. Like this whole concept of centralized versus distributed governance and control impacts all those things. One of the other things that came up in the interview that Keith did was sort of a mention a little bit on the side that we have different storage requirements for what I'll call transactional or operational workloads versus analytical workloads. Andy, can you comment on that?
I mean, yes, it's true. Uh, I
And
Uh, yeah, yes. I mean, you have different needs. You have different storage requirements for those two different types of workflows, and I mean, you can almost apply some of this to your primary versus secondary storage approaches, where the transactional workflows and the type of things that you need to be able to have at hand are going to be considered primary storage, and the analytics and that type of thing would potentially be something that you could do in your secondary storage. This is actually plays into the idea of what we did with at data gravity, where there was a front end node that actually served up your storage, and there was a back end node that was the secondary node on the storage, but that was the one that was actually doing analytics while the front end node was serving the storage. And yes, you need to approach these two different types of data entirely different ways. Um,
Yeah,
and Go
I
ahead.
would contend that. In the old days, yeah, that was very true. But in these days and ages, you can have transactional data sitting on things like object storage. I mean, obviously they're buffered and stuff like that, but it doesn't matter as much anymore where the data resides, as long as you have sufficient quote unquote middleware to deal with it.
Well, yeah, I mean I agree with you entirely there, and my take on object storage is it's basically a file system without a directory structure.
Yeah, more or less. Although it's immutable. That's the other side. Yeah.
immutable. Is it?
Well, I
Well,
mean, everything is more, let's say, blended than in the past. I mean, if you think about in the hard disk era, you had to compartmentalize every single workload application because you wanted to, take advantage of the internal tracks for faster access. Okay, just get that millisecond from the fast tracking, but in other cases short tracking, sorry, but in other cases you wanted also to use the hard drive for archiving, so you use the second part of disk to put the data that you never access. And so that was a lot of work behind a single system. And now you have flash memory. Okay, so all primary storage systems, and again, primary in the sense of flash arrays with block access and file access, they are all flash. Even object storage is all flash now. So you
To a
you don't
large
have,
extent, the ones that are fast. Yeah, yeah, yeah.
yeah, the fast object stores are all flash. So
Yeah,
you don't really care about the type of workloads to some extent. Okay, so I'm oversimplifying, but actually you can have many more workloads in parallel. They don't really mess up with each other. And again, if you have enough middleware, you can optimize all the writes and all the caching that you need. So it's also true that many databases now use object storage in the backend, maybe not for the transactional part or the most active part, but parts of the database are stored in the object store. And
excellent. Yeah,
yeah,
absolutely.
yeah,
and object store are starting to act as databases. Think about S3 Select. S3 Select, you put a CSV file as an object, and then you can query the object. I
Mhm.
mean, it was impossible a few years back, but now it's
Yeah.
something that, and you
well,
are
I
offloading
mean,
some of the application intelligence from
I think
the
that
there are. Go ahead, Andy.
I was going to say, I think to further expand the comment I made to start off here, with the transactional data, you also need to think about sequencing and access, and how to handle multiple access, where quite often with analytics, it's something that it's a single access. There's only one thing accessing it, so you don't actually need to have any way of locking the data or making sure that things happen in appropriate sequence, as opposed to analytics, where lots of times you actually want the analytics engine to be very close to the data, so you want to have very fast access to it, and
But
you might
but
not actually.
but analytics started out being a distributed Hadoop cluster with triple redundancy of the data, and it was all distributed across dozens and dozens of servers. So it's not a single use environment. It may seem that way at the highest level of the structure, but if you look at data lakes today, they are multi-server clusters with multiples
That's
ents of
I,
storage.
I'm not disagreeing that the data lakes are very large. It's just I don't think that you necessarily need the transactional consistency that you do with
Yeah.
front end primary data.
Well,
Yeah.
it's becoming more and more. I mean, so think about object stores again. A few years back, they were all eventually consistent. Now, many of them, the majority now, is strongly consistent
Yeah,
because
yeah.
the type of
Well,
interaction that we do on these objects is way more frequent than in the past. So,
it's almost
and
transactional level. Yeah,
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 I mean, for some workloads, it's critical to have this kind. I mean, there are several updates on the same object in just a few seconds, and you want to be
right,
sure to read, what you wrote.
Mhm.
That's the
right,
thing.
right. Yeah.
And
And
we're back to definitions where what does analytics mean, right? So self-service BI against data lakes and transactional databases is just a bunch of people connecting to the data and doing their stuff with it. And then a well-managed, pre-configured data warehouse that just runs almost batch-like loads on a batch-like processing. It's a completely different being, right? Than I mean, they really are. They're not transactional, and typically, we don't update data warehouses. We just append to them or delete in batch and re-upload and those sort of things. So it is kind of a trick question because just like databases aren't one thing, analytics aren't just one thing either, right? But are there different I know, Andy, you agreed that there are different storage requirements, but does it get down to the level of whether or not it uses block or object storage approach to it, transactional versus analytical?
Again, it's just whatever you want your middleware to do.
Exactly,
And
exactly.
it's I don't at the end of the day, I don't really care how you store your bits, and everybody has their own flavor of middleware that they actually want to use to get to it, and that's a matter of how you prefer to consume it.
Right,
And
right.
I
Or
and
mean,
one
store it. Yeah,
nobody sits around saying I'm concerned about what blocks this stuff is stored in,
yeah,
unless you're a storage engineer.
yeah,
And this is the type of stuff that it's like nobody really gives a shit how the stuff is stored underneath. Kadar can uh,
yeah. I
delete
mean,
but
that if
my
you
consider that
storage
everything
engine
is changing, and if you look at the infrastructure, the abstraction that we have now in the infrastructure, think about DevOps teams. I mean, some of these guys don't really understand what they have underneath their application,
yeah,
and they start using object storage as primary storage just because it's an API that they understand and they can use easily, and it's portable and everything, and so they start using it. I mean, it's not that file or object is better. It's just the API is more in their way of thinking.
doing
So
business, developing software. Yeah, yeah, yeah. Exactly.
yeah, and in spite of them being both developers and operations people who are supposed to understand both how computers work and how they use them.
yeah,
yeah.
I
That's
mean,
been my experience. They also,
most of the DevOps team understand storage in storage classes. Right? Kubernetes guys have
yeah.
faster, fastest, and they think, okay,
Yeah.
faster, so it's solved. Not really, but
Well, now you're preaching to me as the choir because of course these people also don't care about my responsibilities, which is making sure the data is the right quality to meet the business needs. Because you're right, they focus on performance and performance for delivering code and performance of an actual system. But let's not care about whether or not this Karen Lopez is the same as that other Karen Lopez. That's my normal rant there. So it's the separation of duties that are important so we can have specialists, but also that we have to come together and I can ask questions like, does it make a difference between object and block? That's not something I have to worry about in my day-to-day life,
Well,
but I
yeah,
should understand it more.
yeah, it's a matter
And
of
you
like,
shouldn't.
it's their job is to make sure the code is right. They don't really care if the data is right underneath it.
That's right. Well, they care, but just not enough. They're never going to love their data the way Data Chick loves their data.
Right.
So one of the things in the interview that Keith did, there was a lot of talk about high performance computing and how that was different and how it's the same. I know, Andy, you and I have talked in previous things about special storage needs based on different types of high performance computing. Did you want to revisit that just a little bit about how storage is impacted within the different types of high performance, like AI versus ML versus massive
Um,
compute, massively parallel compute, those sort of things?
yeah, to some extent, I don't recall exactly what we were discussing, but I mean the idea of high performance storage or high performance computing storage has kind of morphed over the years as well. Where high performance compute used to be like the world of researchers, the world where you were trying to do a zillion different computations to figure out like where a proton is going to end up in your high speed accelerator or whatever. And that type of thing is what high performance compute was largely used for a while ago. And today, you get into the AI and machine learning world. That is where an awful lot of high performance compute type resources are needed. And the idea is that in research you need to be able to pick through an incredibly large set of data to be able to do the calculations you need to be able to find things. And with machine learning and some forms of AI today, you need to be able to go through an extremely large set of data to get inferences from it and figure out the information you needed to do. And I remember we discussed high performance computing at one of the field day events, but I'm struggling to remember exactly what we discussed.
We were talking about AI, but it was good. Ray, what do you think
Yeah.
about that?
Well, so machine learning is effectively these days it's consuming awful lots of sequential data, whether it's visual, audio, or textual or whatever. But it's consuming this data, and it's consuming it lots of times. And during the training activity, you may be consuming this stuff, 1,000 times or 64 times, depending on what you want to do. But most of that data that they're consuming, they effectively bring it into storage or bring it into memory rather, and they're consuming it from a memory type of structure. So, or they're bringing in batches of it into memory and consuming it that way. The high performance guys have always been, massive levels of file. I think Enrico mentioned earlier Luster, Ceph, BFS, Spectrum Scale. There's probably a half a dozen other ones that I don't even remember. But they had massive amounts of effectively file data that was petabytes or exabytes or yottabytes of data that they needed to go through and run some serious Fortran against, right? Serious scientific computing against. You could argue that machine learning is a follow on to that sort of thing. It's a lot of mathematics differentiation and that sort of stuff done on multi-core devices, whether they're GPUs or CPUs or massive HPC clusters. I don't know, Enrico. You had a pretty good discussion there in your email earlier today.
Well, in general, I think that so HPC in general is first of all the architecture are always very very balanced. It's not that you have a storage that is particularly uh, more powerful than the rest of the infrastructure. So you see every time that they announce a new supercomputer, the best supercomputer, you also see a new architecture attached to it. So, and even the last supercomputer that was, I think, in the US is now the fastest in the world. They spent a lot of time talking about how the storage infrastructure works. And again, it's not only a piece; it's very complicated. It's files. There is a block. There is tons of components. So and it's layered architecture, but the problem is, these guys work. So HPC is something that is a really, really different from what we have in enterprise. Even the largest enterprise usually doesn't have the needs of these guys. Yeah, and they are for massive optimization. Even zero zero something means a lot for them, and
Right, right.
they use this massive architecture, hyper scalable. Yes, they use Fortran, but they have also 10,000 nodes. I mean,
Yeah, yeah, yeah.
so
And it's
Fortran. So
also the networking is very, very specialized as well. It's not your off the shelf InfiniBand or Ethernet or something like that. It's always
yeah,
so
so
extreme.
and so even if they talk files, they don't talk 99% of the file about NFS or SMB. They have a client installed on. So these file system have a
POSIX. Yeah,
client
yeah.
and a POSIX client, and
Right.
of course, they are both very advanced, but also very conservative, because it's not easy to design this kind of infrastructure. I mean, and you try to,
Exaflops.
Well,
yeah.
I think
Right.
Keith actually summed it up best a week or two ago when he made the comment that it's like mmap is not a new function call. It's these programs have actually been mapping files into memory for decades now, and that's typically the way that an awful lot of these things are going to operate on the underlying stored data. No matter what, they're going to map it into memory, and they're going to treat it as if it's just a memory object. It's one of the things that I've actually been discussing elsewhere is electronic design automation, and this is another case where this type of HPC function comes in, extremely handy. The idea that you actually need to run a zillion simulations on what's going on inside your silicon to actually get it to work the way you want it to, and
Yeah.
this is another application for HPC. Um,
Like
and
activities. Yeah.
I
yeah,
would like to make a distinction between commercial HPC and academic HPC. I mean, so even if EDA is really 100% an HPC workload, usually is run by component manufacturers, and they tend to save money. Okay, so you can find a lot of NFS, a lot of standard component, and many of these workloads are moving to the cloud because they don't need to run these workloads all the
All the
time. So they
time.
don't really,
Yeah.
well,
yeah, they
right,
don't
and
really care about the infrastructure anymore. So actually, they care to save as much money as they can. So they move to the cloud because they can turn it off and on when it's necessary. Okay, and the data is still there because the dollar per gigabyte in the cloud is very low. It's when you access and move it that is expensive. So the HPC in the academia is different because they make huge investments
Mm-hmm.
and they need to, every penny has to count.
Yeah.
And so it's everything is hyper optimized. Some of this stuff is customized, and in academia are really, really, really opinionated. Like it's
Unlike us.
no,
Unlike us.
yes,
no opinions here.
Yeah, yeah,
no,
exactly.
but
I,
the
I
difference is that an
I
enterprise, you can find somebody in enterprise that listens, and at a certain point they make a decision that is more a business decision than a technical decision. If you talk in academia, where you have all these guys that study every day, computing science, computer science, etc., etc., they have very strong ideas. Sometimes they're wrong, but most of the time are really
as most opinions are. So
Yeah,
I really
but again, it's very difficult to force something different of you if it
But
doesn't come from us, from them.
I
yeah, yeah.
Yes, exactly.
Something like
Yeah,
that.
so I think this is a good thing, and maybe just the reflection is that, like you said, research organizations, including universities, they invest heavily in their HPC because they can always make use of that time, whereas enterprises just sort of need to rent HPC type services. So as a
Depends
service,
on the
more
enterprise, right? I mean, to a large extent.
right.
Yeah, yeah. To a most part, yes, I agree. But
yes,
Yeah,
some of these
not
enterprises are
always.
doing it more often than not.
yeah, I
Yeah,
agree with Ray on that case. It's I can actually think of lots of times where both enterprise and government would have need to
yes.
actually have their own resources.
Yeah.
Yeah, just today, NOAA, the weather people, right, just announced they did their press release on two new supercomputers that are being deployed. Their General Dynamics delivered these two Cray supercomputers that puts them, now I've forgotten already the metrics on it because I just read it, but it's 3 times more performant than what they've had in the past. So definitely that organization, which I also consider like an operational and research organization for sure. But if when I say enterprise, a lot of times I'm talking about, retailers, insurance companies, um, you
Financial
know,
companies, banks, stuff like that. Yeah.
that maybe are using HPC type technologies, mostly
Well,
for enhancing data that they have or calculating models.
I think there's an awful lot of modeling that goes on that way, but I also think that both in electronic and physical design corporations, there's an awful lot of need for high density computing and
Yeah,
high density storage. And I don't think that those companies are necessarily, just renting it.
yeah, agree.
Yeah.
I agree. I mean, basically, the big answer is it depends, right? So the sidetrack I wanted to make, since two of you mentioned it in the interview, the the researcher indicate or the person from the university indicated that Fortran is the best language for doing high performance computing. Now, my take on it might be different than yours. Really short, really quickly, what do each of you think about that statement? Because I thought it was a great statement.
Python. Why would you use Fortran anymore? Python's the answer. The
I'm sure
problem
you
with
can use
Fortran,
Python to
it's
call
been around
Fortran.
for 50 years or 60 years now, and so every one of these applications that they've developed over the last half century is written in
Yeah.
Fortran. Okay, but if you're going to do something today, it would be Python. I'm sorry, just an
Yeah.
opinion, my humble opinion. I don't know.
When I worked on a Fortran project went way back when I was in university more than 3 decades ago, and
I've
I
done
thought
more
it was,
Fortran than I care to admit, Karen.
but I thought it was an old language then, 30 some years.
It's it was an old language then, and it's my I mean, yes, there's an awful lot of stuff that goes on in Python these days, but my continued take on this is that if you're actually going to take advantage of your high performance compute resources and the storage that's underlying it, you really need to be running a compiled language, and that's when one of the places where Fortran comes in. That would be places where C would come in as well. Um, I I have not been impressed with any of the Python compilers I've seen out there, but I really haven't been staying on top of it
Yeah.
either. Python is largely an interpreted language, and if you're going to actually spend the money to do high performance computing, do it in
Yeah.
a language that actually is suitable for doing high performance programming.
If you
And
look at
to be honest,
any of the machine learning activities going on and NVIDIA superclusters and all this, it's all Python.
yes, the
It's
front end, the
supercomputing is
front
all
end,
Python.
the libraries are not in Python.
No,
I'm
no,
sure we're
absolutely, absolutely.
trust.
But the functionality that sets it up, the
Yeah,
model, and starts
yeah,
using it in our data.
the logic. But when you call the
But
specific function
yeah,
behind there is a library developed in C or
the
Yeah,
something. Well, in
I
any
see.
way, Fortran is common not just because we are talking about a university and probably somebody taught them Fortran when they started, their first compute science course. Like,
Yeah.
I mean, fortunately, they didn't learn Java or Pascal, but
No, so
But
this is all great, but I want to make sure we have time. Like, one of the other things that we're supposed to be talking about, besides the fact that someone believes all storage will be object in the future, kind of embedded in some of this discussion is, do you think everything we do is going to become cloud native and cloud like architectures, as maybe not in my lifetime, but in some people's lifetimes, people that are working in IT right now?
You have to define your terms here. Cloud native means
I
something. A cloud cloud running on the cloud is another thing. I
Yes,
think
I know.
I think you could state that, if you have to scale, if you have to distribute your workload, I think cloud native functionality makes a lot of sense there. But not every workload needs to scale from one server to 10,000 in a matter of seconds, If you're an organization that has the scale requirements, I think cloud native makes a lot of sense.
Yeah.
and
Anybody else?
honestly, so and again, everything is developed in layer on top of layer on top of layer. So if we dig still in a bank today, we find that there is a huge mainframe behind a lot of microservices, a lot of other stuff. So I mean, when the last mainframe of this world will die, then we can think about everything will use the next technology. But I don't think that
The
it will happen.
mainframe will never die. It,
Yeah,
it can't.
and
It
it will
won't
happen
die.
for many other technologies that we know. Even tape will never die. I mean,
Tape will
Yeah.
never die.
Um,
Why would it die?
And
COBOL will never die. IBM just announced today their development of their mainframe, their ZOS, their ZOS on a VM just for dev tests, so like an emulator, so that people could do that because mainframe's not going to die.
yeah,
Andy, do you
and
Mainframe
have
will
any
never
thoughts?
die.
my it's cloud native or not. I think people don't really care. They want the consumption model where they can get the resources they need when they need them, and it's whether you call that cloud native or whether you call it consumption driven. Um,
Yeah, I think you're
you know,
confusing the terms here, Andy. I think cloud native means really containers to a large extent. The Cloud Native Computing Foundation is all about Kubernetes, containers, and how those operate. But if you look at the
Mhm.
cloud, a lot of the functionality running on the cloud is not cloud native, quite frankly. I mean, yeah, the hyperscalers underneath it, probably all cloud native. But, I spin
okay,
up a couple of servers to do something. I'm not necessarily using containers or Kubernetes, which are, in fact,
okay,
two different things.
okay. So nobody gave me the glossary of what cloud native meant in this case.
Sorry. I just wanted
That's
to
so
make
many
sure you
Uh,
were aware.
okay, no, but I mean that if that's what we mean by cloud native, then no, it's like no, I think that people will consume resources the way that they want to consume resources, and they will make it available to themselves that way, and
Yeah.
that's I don't think the VMs are going anywhere for as long as mainframes are not going anywhere.
Exactly.
Oh, wait, come back in 15 years and VMs will be the old way of doing things. So,
Let's hope.
so we've got like 1 minute left. So, what I'd like you guys to tell first, I want to thank you all for having this debate discussion. I want to, me, I
Argument,
want to.
argument.
I want to continue it on social media as well. But I want to ask each of you to tell me, where can we find you if we want to argue with you on social media? Enrico?
so you can find me on practically every social media, but mostly on Twitter and LinkedIn. And to
Mhm.
find my profile, just Google me because there are not many Enrico Signoretti on working in IT.
Yeah. Ray?
Mostly on social media. I've been kind of going off that tangent. I'm on Twitter at Ray Lucchese. I blog at rayonstorage.com. I'm a podcaster on Graybeards on storage.com. So any of those you can comment at will. Again, and yes, you can certainly Google me, and there's probably 4 or 5 Ray Lucchese's, but not many in storage.
So we should just email you our debates, is what you're
Yes,
saying.
if you wish, and I could
And
happy to send you that if you will.
And you can find me on Twitter at Andy Banta, and there are multiple Andy Bantas on Twitter, but there's only one that has the handle at Andy Banta.
There you go. That's how Twitter works. So you can find me as Data Chick because with a name like Lopez, I have to have a different name. So thank you guys so much again. And I want to thank CTO Advisor and Keith for inviting us to argue in public.
Thank you.
Thank
Thank
you.
you.